Welcome back, Trig students. This is going to be your second lesson this week, going over linear and angular speed as well as arc length. So it's kind of a bridge or a stepping stone off of the previous lesson. So if you have yet to finish angles and radians, the 5.1a lesson, the video was right before it. So go back, finish that video because the stuff we learned in that video is going to be in this video. So if you didn't understand that, it's going to be really difficult for you to understand this one. So complete that video, go through some of the homework, and then we're going to get started here with bell work, then the homework quiz, and then we're going to go through the objective and essential questions. So make sure your notes are out, and as well as a pen, paper, make sure you have a highlighter, anything that you need so that you can actually follow along as I go through the video. And then also, if you have yet to pick up your TI-36X Pro, you should probably do that. That would be amazing. All right, let's get started. So these are questions that are taken directly from the homework quiz. So these questions, you may or may not see them on the homework quiz, but you will probably see something like them. So let's go through it. Take a minute, write them down, pause the video if you need to. All right, let's get started. What? I thought I had more on the other side. Let's get started. Find a positive angle less than 360 that is coterminal with the given angle. What does this look like? So this is negative 955 degrees. So this means, since it's degrees, I need to make sure I add 360 degrees. Why do I add instead of subtract? Because if I subtract, that just means I'm getting more negative. But I don't want more negative. I want to find a positive angle. And I need to continue adding 360 until I'm also, not just positive, but also less than 360. So if I add these together, what I get is negative 595 plus 360 degrees, because that's still not, it's still not positive, and it's definitely not less than 360 degrees. So I need to add another 360 degrees, and this equals negative 235. Same thing, I need to add another 360 degrees. We're getting close, and this will finally equal 125 degrees. Boom. Is that less than 360? Yes. Is that a positive angle? Yes. We're good. We're solid. All right, find a positive angle less than 2 pi that is coterminal. Same exact thing, but now it's not a degree, it's a radian measure. So I'm going to subtract 2 pi. Why am I subtracting? Because this is already positive. Okay, so if I subtract 2 pi, I will try to get a positive angle as well as one that's less than 2 pi or 360 degrees. This is always understood 1 underneath here. I need to get common denominators. Times 5 gives me 5. Times 5 gives me 10. So what is 23 pi minus 10 pi? Well, that's 13 pi all over the common denominator of 5. Now, how many times does 5 go into 13? Definitely more than 2 times, which means I'm still above 2 pi. Even though it's positive, I'm still greater than 2 pi. So I need to do it again. I'm going to subtract 2 pi, or I can just kind of jump the gun here and just say I'm going to subtract 10 pi all over 5, because 10 pi all over 5 is the same thing as 2 pi. So we just did that. 13 pi minus 10 pi is 3 pi, and this is all over 5. Is that a positive angle? Yes. Is that less than 2 pi? Well, let's find out. How many times does 5 go into 3? Not even once. So that means it is less than 2 pi. Perfect. Let's go to our last one. Convert the angle in degrees to radians. So that means I need to multiply this by 180 degrees divided by pi. What happens to my degree symbol? Oh, shoot. Don't do that. I'm not thinking clearly. Oh, shoot. This is actually pi. So erase whatever you had. Such an awful math teacher. This is technically all over 1, so your zeros go poofy, your degrees go poofy, and so what are you left with? You're left with 24 pi all over 18. That's what you're left with. And this, of course, simplifies down to 4 pi all over 3. Perfect. Perfect, perfect. So these are the 3 that I want to go to. These will more than likely be on your homework quiz in one way or another, so make sure you're writing this down, paying attention. As soon as you're ready, go to the homework quiz. It is about 5. I'm going to erase this. Go to the homework quiz. It is 5 questions, 20 minutes, open notes. Obviously, you can use the videos I have, but I don't think that's going to help you because, you're pressured for time and you need to go through the time. Afterwards, please review your answers. Send any partial credit requests. Those of you who are familiar with my class already know this. You can send any partial credit request to me. What does that mean? That means that you can literally send, like, let's just say if you had 5 over 4, but the actual answer for Math Excel was 5 pi all over 4. Well, clearly that's just a simple mistake, right? You accidentally forgot the pi, all right? So I can give you at least half credit for that, whereas Math Excel would completely mark you wrong. So it will mark you wrong, and then you say, hey, Mr. Carlson, on this homework quiz, 5.1a, angles and radian measure, they marked me wrong here, but I just forgot the pi. Can you give me some partial credit? I will respond saying absolutely. Not really. I probably will never respond to those emails, but you will see them updated into Synergy, and you will see that I will say something like corrected. So in Synergy, I will say something like corrected, and then this was the actual one, but this is the new one or whatever. Okay? So that's what I mean. So when I say corrected, that's what I did. So feel free to send me those through email. If you don't send me partial credit requests, guys, I will not. With how many students I have in this class and how many students I have in first hour, I have over 40 kids in both classes, and that's not even including my fourth hour. Okay, so I have a lot of kids this quarter, all right, and a lot of online stuff. I'm grading a lot. I'm telling you, if you do not email me, I will not go into your Math Excel. Speaking of which, if you're not on Math Excel, that's a problem because you need to do this assignment. So if you're still not on Math Excel, talk to me. Okay, you need to talk to me right now. As soon as you're done with that, make sure you start beginning your notes because that's what we're going to be doing next. Arc length and speed. What is arc length and speed? What is arc length and speed? Well, here's the objectives. I can find the length in the circular arc by using the arc length formula. And I can use linear and angular speed to describe motion and circular path through conversions and so forth. How do I calculate an arc length? Is one of our essential questions. And how do I convert between linear and angular speed? That's angular speed there. I love this meme right here. I wonder if I can find the arc length of the rainbow in my imagination. That's pretty brilliant, right? I mean, for real. All right, let's start. Remember, you should be taking notes. Okay, first things first, I want us to recall from yesterday's notes that the radian measure here is this formula. So if I have a radian measure theta, it is therefore S, the arc length, all over R, the radius, radians. Okay, that's what I have. And that's just from yesterday. Now, this is what we're going to be learning today. Think about it. We can use the radian measure formula, which is this one, to find the length of the arc of a circle. Just solve the formula for S. How can I do that? Well, if I have theta equals S all over R, all I have to do is just multiply by R. That goes poofy, so what does this give me? It gives me S equals R times theta. This is my, what we call arc length formula. So make sure you are writing that down. Arc length formula. Perfect, that's an L. We're going to be working with this half the day. So half this lesson we're going to be working with it. And this lesson will definitely not be as long as yesterday's lesson, I promise you. All right, so let's just say we have a basic question here. Okay? A circle has a radius of 10 inches. Find the length of the arc intercepted by the central angle of 120. So what does that mean? Well, first of all, my S equals R times theta. This is my formula that we just found. And if I have a radius of 10 inches and I have a central angle of 120, I want to know what S equals. I don't know what S equals. So here are my actual variables, 10 inches, and then my theta equals 120. Now here's the problem, guys, and pay very close attention. Pay very close attention. Here's the problem. This is in degrees. This is coming from a radian formula. Do you think radian and degrees are compatible? No, which means I first, before I even start multiplying this stuff together, I can multiply 10 times something, okay, theta. I need to multiply by theta, but what is theta? I don't know. I don't know what theta is in radians. I only have it in degrees. So really the first step is I need to take this 120 degrees and I need to change it into radians. So how do I do that? Pi all over 180 degrees. Okay, so that goes poofy, those go poofy. So what does this equal? This equals 12 pi all over 18. And then I can simplify it down just a little bit more, so each one is divisible by 6. So that means divisible by 6, that is 2. Divisible by 6 is 3. So this is actually my angle measure, theta. So that means I can go ahead and erase this and say that my angle measure, theta, in radians is, that's awful. Hope the homework quiz is good. Remember, if you have any questions on the homework quiz, they're not retakeable, unfortunately. Just do your homework, try your best. They're worth a really, really small grade. And they're optional after week 2. So beginning week 3, after week 2, they're optional, the homework quizzes. So if you didn't think you did really well on the homework quiz, that's okay. Don't freak out. They're not going to be worth that much. And if as long as you maintain an 85% or above, they're optional for you. But feel free to always ask me, like, hey, I don't know why I did this or what went wrong. By all means, ask me. Okay, so getting back to here, let's start multiplying this out. So this equals 10 times, this is technically over 1. 10 times 2 is 20, so this is 20 pi, and this is all over 3. Okay, so this right here is actually my length. Okay, this is actually a length, and honestly, most of the time, Math Excel will want you to actually put this length in. There's no more radians here at all. The radians kind of go poofy away. Okay, how do they go poofy? Technically, so this is rate. So I'll show you. If this is going to confuse you, don't worry about it. This is just kind of for those who are like thinking, what happened with the radian measure? So this is 10 inches, and we say per 1 radius. And then we multiply that by 2 pi 3 over 3, and then of radians. What happens to the radian measures? What am I left with? Inches. So technically this right here is inches, and inches is exactly the kind of measure we need for a length of the arc length, right? So how do I solve that? 20 pi over 3. Well, first of all, you can use your TI-36X Pro. But if you don't want to use that, then you can just do 20 and then pi divided by 3. And this will give you 20.9. 20.9 inches. So 20.9 inches. That is my arc length. Good? Let's erase. Yeah, I already went through that. Yeah. That's great. Boom. Okay. All right. Let's go through this one, 310. I have a central angle of 310, a radius of 5. These are really important. Make sure you understand that. I want to know what, in terms of pi, so don't give a decimal. It wants it in terms of pi, what the length is. So what is S? That's what we're trying to find. Okay, well, first off, again, this is 310 degrees. I don't need degrees. I don't want degrees. So I do it over 1. And this is pi all over 180 degrees. What happens to degrees? Go poofy. Zeros go poofy. What am I left with? 31 pi all over 81, or 18, not 81. Okay. Now this is technically radians. Second step. Okay. My formula, S equals R times theta. This is my formula. I want to find what my arc length is, right? My actual length. I'm given a radius of 5, so this is 5 feet. And technically, like I said, this is 5 feet per, divided by, per 1 radian, or radius, times my new best friend found theta. I found my new radian measure for theta, so this is 31 pi all over 18. Now again, this is technically radians. We never really write it, but they don't just go poofy or vanish away. They actually just go, well, they do go poofy, but we usually don't write them, so it's not like they're invisible. I don't like writing radians all the time. So technically this is 5 times 5 feet times 31 pi all over 18. Now again, I don't want you, and neither does Math Excel want you, to put it in terms of decimals. So all you have to do is just multiply across. 5 times 31 gives you 155, and then pi, and then this is all over 18, and this is feet. Perfect. If they did ask for a decimal, you would just plug this into Desmos or your TI-36X Pro, and then this is feet right here. Perfect. Fantastic. I'm going to erase that. Make sure you get that stuff down. Next one. Again, I'm given basically the exact same stuff, so I'm going to go through this a little bit faster. So what is 170 degrees in radians? That is going to be 17 pi all over 18. And then the second step, I again have S equals R times theta. So what is that? Well, my R is 14, and I multiply that by 17 pi all over 18. What does this equal in terms of pi? I want it in terms of pi. What does that equal? It equals 119 pi, and this will be inches because my radius is in inches, and we need a length, all over 9. Okay? I kind of sweetened that one. I didn't really work it all out, but I just kind of sweetened it for you. Sweet. Let's go for it. Now, more examples. These are going to be a little bit trickier because of what they give us. So you need to pay just close attention here. I'm almost confident one like this will be on your quiz. So just FYI, I'm fairly confident one like this will be on your quiz. So find the angle measure, the radian measure, theta. What is that? I don't know. Of the central angle of a circle with a radius equals r of 100. And then inches, and then intercepts the arc length of 70 inches. Okay? All right, so now here's the thing. They're both inches, so that's good. If they're not both inches, we may have an issue here. Okay, but since they are both inches, we are solid and we can move on. So my first step is, first of all, getting my formula down once more. Okay? That's my first step. My second step is actually solving this out, okay? This is my formula I started with, but it's not the formula I will be using. The formula I can use is really just this. So S all over R. So this is the formula that we learned today. This is the formula that we learned yesterday. And which one are we solving for? We're solving for theta, not S. Now, could you technically plug this stuff in and just solve for theta that way and then just divide by R? Yeah, obviously. Okay, but it's maybe easier just to use this one because we are trying to solve for theta. Okay, so 70 inches is on top. Now, what happens to the inches when the 100 inches is on bottom? The inches go poofy. Okay, so since it goes poofy, this equals then 0, 0. This equals 7 all over 10 radians. Now you're probably thinking, what? Where does this radian come from? I'll show you just really quick. This is 70 inches divided by 100, okay, inches per 1 radian or radius. So really what happens is this then gets, since this is flipped over, this actually becomes this. So 70 inches times 1 radian, because I flip it, I do the reciprocal, I multiply by the reciprocal, 1 radian all over 100 inches. So that is how I get the radian measure in there. I usually don't show that, but those of you who are really finicky and like, seriously, where'd you get this? Like, that's where I'm getting it, okay? The radian measure is implicitly kind of invisible in the unit measures. Okay? And of course, that goes poofy. This is all over 1. That goes poofy. I'm still left with 7 over 10. Smiley face, okay? All right, let's see what we got here. I'm going to erase this, so... All right, I told you yesterday that you'll probably do questions that involve a hand, a minute hand. And this one can get really complicated, so pay very close attention. Okay, the minute hand of a clock is 6 inches long, let's just say, and moves from 12 to 10 o'clock. How far does the tip of the minute hand move? Okay, how far does the tip of the minute hand move? Now, what it's really asking is, what is your S? That's what it's asking. It's not asking you the theta measure. Okay? And that's the important part. It's asking how far. Far is a distance. If it's a distance, it's not a measure, an angle measure at least. It's a measure of length. So when it says far, it means distance, and distance means a measure of length, not a measure of angle. A measure of angle is theta, radians, degrees. A measure of length is distance, that's arc length. Okay? So that's the first thing you need to notice, is that it's actually asking you what your S is. We want to keep things in terms of pi, and we also want to then round to 2 decimal places. So how do I actually solve this? Well, the first step is this. I need to make sure I write down my formula. Okay, S equals R times theta. I want to find S, so that's the formula I'm going to use. Okay, I am given the fact that R equals 6 inches. Now watch what I do here. Per divided by per 1 radian. Okay, 6 inches per 1 radian. That's the only thing I'm actually given here. That's my variable. I am not given the theta, which means I need to find the theta. All the examples up to now, we have been just given theta and given either R or S, and then we have to solve for the last remaining variable. Now we're just given one variable, and we need to solve for what the other 2 variables. But we can't solve for S unless we have theta. So the next thing that we do is we have to solve what theta is. So what is theta? Question mark. Okay, well, let's think about it. From 10 to 12, okay, or from 12 to 10. So when it goes from 12 all the way, so 12 o'clock, let me try to draw it here. So this is from 12, this is 12, and it goes all the way to about 10. 10 is like somewhere around here. So that means this hand goes all the way from there to there. How many revolutions is that? What's the percentage, what's the fraction of revolution does that give us? That's what we really need to find. So how I do that is just take 10 divided by 12. Why do I do 10 divided by 12 and not 12 divided by 10? Because if I did 12 divided by 10, that would be a full revolution plus a little bit more. What we are told was that it goes from 12 to 10. Notice how there's this chunk that's missing. All we have covered is this much. All we have covered is this much. But there's a chunk missing, which means it's not a full revolution. If it's not a full revolution, I can't do 12 over 10. I need to do 10 over 12, so that way there's like 12 doesn't go into 10. Right? But if I did 12 over 10, then obviously 10 can go into 12 and it would be past a revolution. So really what I want to know is how much green revolution is this? Does that make sense? I hope it does. I simplify this, and this tells me 5 over 6 revs. It's about 5/6 of a revolution. Okay? Now watch what I'm about to do here. Okay, now watch. This helps me. It's a revolution. It's not the theta. It's a revolution. I need to therefore now find the theta measure. This is just a rev. Okay, the revolution. It's how it goes around the circle. That's the kind of percentage or fraction it goes around the circle, but it's not my theta. My theta is an angle measure. This just tells me a different kind of measure, an angular measure. Okay, so now this gives me, if I do theta equals, I can say 5 over 6 revs. And now watch what I'm about to do here. I'm going to have to do some hardcore conversions. And I'm going to multiply this. Watch. I'm going to multiply this by 2 pi radians. And how many revs are in 2 pi radians? 1. Uno. Okay, so 1 rev is per 2 pi radians. When it goes around the circle completely 360 degrees, that's completely 2 pi radians, and that is 1 full rev. We did not get to 1 full rev here because this is 10, this is 12. I did not get to 1 full rev. So that means I have to kind of still find my theta by doing some conversions. That goes poofy. And then now what I'm left with is 10 pi all over 6 radians. Is a radian measure an angle measure? Yes, it is. So I can then simplify this down to become 5 pi all over 3 radians. This is my theta. Wow, but that's a lot of work, right? Like that's pretty intense though. Now that I found my theta, let's go to step 3 and put everything together. So my S equals R times theta. What is my S? I don't know. That's what I'm trying to find. What is my R? My R is 6 inches per 1 radian. Okay, and what is my theta? I just found it. It is 5 pi all over 3 radians. Okay, what happens to the radians? Goes poofy, as it should, because it's arc length. We need a length here, and it will come to be inches. What's 6 times 5? That is 30, and then I'm still left with a pi here. Don't forget your pi, and then all over 3. Yeah, what's your problem? If you forget your pi, I mean, who can forget pi? Pi is so tasty. So right here, 30 pi all over 3. Of course, that is not simplified, even though I boxed it. This simplifies down to 10 pi inches. So something like that would be partial credit. So if you do a quiz and you just didn't simplify it all the way down, MathXL will count you completely wrong, but obviously it's right. So I'll probably give you half credit on that. And MathXL will give you no credit. So is it beneficial for you to send partial credit? Yes. So that is your final answer. Not this one, but this one is your final answer, 10 pi. It also wants decimal places, so I'm going to go all the way over here. And this actually simplifies down to be S equals 31.42 inches. So once in pi form right here, and also once in decimal form. Fantastic. That's amazing. All right. I want to erase. All right, this one. What is the length of the circular arc? So that means, once just define S, intercepted by 2 radii that are 6 inches long, whose angle is 3 radians. Okay, what does it mean by intercepted by 2 radii? First of all, it just means this. So this is your S. I don't know what the S is. And this is your theta. So this is 6 inches, and this is 6 inches. These are the 2 radii. That's what it says. That's what it means. Okay, so that's my first step, just kind of getting a basic picture. That's what it looks like. My second step is going to be S equals R times theta. Okay, and then I'm going to list out my variables. R, of course, equals 6 inches, and then my theta is 3 radians. Okay, so that means since I have that, I can start solving. So that means this equals 6 inches, and then times 3 radians. Now remember, this is 6 inches per 1 radian. So what happens to the radians? They go poofy. And this becomes 18 inches for my S. So again, that was another basic one. Very, very simple. Sweet. Let's go on and move. All right, so now this kind of introduces with the conversion factors, this introduces us to what we call angular and linear speed. Angular and linear speed. So linear speed is what this is, okay? These are some interesting letters. So V equals S all over T, okay? It's actually a Greek letter, but I'm just going to say V. This is actually omega right here, another Greek letter, but I'm just going to say W for the not confusing, to make sure it's not confusing for you. Okay, so V equals S all over T, that's linear speed, and then angular speed is what we call using angles. So that's going to be omega, or W equals theta all over T. Now T, of course, is time. Okay, and that's the first thing I need you guys to know. T, of course, is time, and that will always stay the same. R is, of course, radians. That's going to be always in radius, and that's going to be radians for theta. All right? Now, here's the thing. Here's the important part, guys. You need to pay attention here. What is the difference between linear and angular speed? You guys know this, especially if you drive, and you don't even probably realize it. On your dashboard, you usually have 2 odometers. Not odometers, but 2 tactometers. That's what they're called, tactometers. Where the little like needle kind of goes up and down, right? There's one of them that says RPMs, and there's another one that says MPH, or miles per hour, kilometers per hour. Linear speed, okay, linear speed is MPH, miles per hour. Okay, so it's distance. This is distance per time. So hour in this case. That's how we get linear speed. So if you're driving at all, you are literally looking at linear speed. But it's different than the other meter. The other meter is what we call RPMs, especially if you're driving. So this is RPM. What does that mean? Revolutions per minute. What does revolutions mean? Angles, okay? How it goes around. How does it measure that? Based on your tires. You guys realize, especially if you're driving, if you don't have proper air pressure in your tires, you could actually lose gas mileage. The reason why your car is manufactured the way it is and to get the gas mileage it does is because it's based on and calculated on the tire pressure, how big your tires are. They have to recalculate anytime you rotate your tires, anytime you get a new tire on there or blow up your tires, you need to recalculate that computer there, okay? So RPMs is literally revolutions, so this is your revs for short, per minute or per time, okay? That's what that means, revolutions per minute or per time. Okay, I would show you how these are related. I'm not going to right now. I don't really have time for that, so I'm going to leave it at that, and we're going to go through a couple of examples here. So this is angular speed. This is literally what Math Excel will show you, by the way. To determine angular speed, you want to multiply the number of revs per unit time. So I love this. I just snipped it right from Math Excel because it's so beautiful. It's like, wow, that's so great. So you're going to see something exactly like this on Math Excel. When it says express the angular speed in radians per second. So this is 14 revs per second. How do I know it's angular speed? Well, number one, they told us. Ding, 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 ding. And number two, okay, they also say that it's revolutions. So it's revolutions. Linear speed does not have revolution. It has distance, not angles. Okay, that's the main thing I need you guys to understand. So this is actually a revolution. So how do I do this? Well, I'm going to use what we call railroad track conversions. 14 revs per 1 second. Railroad track conversions look something like this, and basically it's just multiplied in between. You may have learned this maybe in grade school, maybe if you took stoichiometry with Dr. D or another chemistry teacher. This is technically what we call railroad track conversions. And so this then goes to 2 pi radians per 1 rev. This is the missing link that we need. This is the thing that we need to add into this problem. Okay, this is almost like a key factor. When in doubt, just multiply 2 pi radians all over 1 rev. The revs go poofy. What am I left with? I'm left with 14 times 2 pi, which is 28 pi radians. And this is all over. 1 times 1 is, of course, just 1 second. Do I want radians per second? I do. Whoa, there you go. And just for a good measure, let's draw my unicorn. That's the end of the problem. But surely it's not the end of the lesson, so let's continue on. I hope that one was a simple one for you. Now let's kind of learn about how to convert between linear and angular speed. Okay, this can get confusing, but it doesn't need to be confusing. So I'm going to show you kind of the technical stuff first. So this really starts with linear speed, which is v, of a point distance r, which of course r would be your radius, and then omega or your w, that's actually your angular speed. So again, you multiply your r, your distance, your 2 pi radians per your actual linear speed. Okay? Sorry, per your actual angular speed. So that may sound confusing because it can be. Here are your steps. And I'm just going to blow through these really, really quick because honestly, they're not too important. So if you don't want to write them down, like I totally understand because they're really not too important here. So pause the video if you would like, but I'm going to move on. Because once I show you the actual math, it's going to be way easier for you to actually understand what is actually happening. So we have 2 more examples and then we're done, guys. Isn't that great? We're almost done here. 2 more examples and then we're done. So angular speed of a point on a planet is 11 pi all over 14 radians per hour. Dang. But here, notice angular speed. The equator lies on a circle of radius approximately 4,000 miles. Now, technically, that's what they're saying is the Earth. Point on a planet. Technically, that's really similar to the Earth. Am I right? Linear velocity. Now, velocity has to do with distance and time. So linear velocity in miles per hour, like I said, distance and time, of the point of the equator, of the point on the equator. What does this mean? First of all, we want to go from angular, I'm going to say this, we want to go from angular to linear. That's the first thing we want to know. Angular to linear. So what does this mean? Well, the formula I'm technically going to use is your weird looking V here, and then your R, this is your R, times your omega or W. This is your formula. Now that formula you don't really need to use it. Math Excel uses it a lot, so that's why I'm showing it to you. What does it actually mean? Well, our W is what we call the angular measure. And this actually equals, they literally told us this in the problem right here, 11 pi all over 14. And then I'm actually going to say radians and then per hour. Yeah, let's just do per 1 hour. How about that? Okay. We're also missing my R, which is my radius. And this equals 4,000 miles per 1 radian. So, given all this information, given my angular speed, this is what it is, given my radius, this is what it is, I can use this formula then to find out what my actual angular speed, or sorry, my actual linear velocity is. Because again, my linear velocity equals this. So I'll even write it out for you. That's what that V is right here, this V. Yes, that one. That's linear velocity. That's what we're trying to find. In miles per hour, that's what we're trying to find. I don't know that yet, but it needs to be in mph, miles per hour. Okay, that's what my final answer is gonna look something like. So how is this, this world, this planet, whatever? How fast is it spinning? Well, let's try to find out. So I take 11 pi all over 14, and again, this is radians per hour, 1 hour. Radians per 1 hour. I multiply that by my angular, or not my, that is my angular. I multiply that by my actual radius. So this is 4,000 miles, and then per 1 radius, or 1 radian. Okay, those go poofy. And so now what I'm left with is miles per hour. So now I just need to multiply all this together, and you will definitely be using Desmos. Divided by 14. So 11 pi times 4,000. What does that equal? This equals 9,873.5. Sorry, my mouse is being weird. 0.58 miles, because that's what we had, per 1 hour. Boom. Okay, so that is how you kind of convert between linear and angular, how you kind of use these slight small formulas to your advantage. You won't have a lot of questions like this on Math Excel, but you may have one on the quiz. So just do the quiz review, make sure you understand. Okay, I'm going to erase. We have one more question, and it's actually kind of a fun one. I think it's kind of fun. Now, if you guys don't know me, I used to have a Firebird. Firebirds are amazing. It's a nice car. So I used to have a Pontiac Firebird, 1984. It had about 3,000 miles on it when I first got it. Let's just say I was cruising up the I-10 towards the valley. The police officer pulls me over and says, "You're going 2,100 revolutions per minute." Okay? Was I speeding? That's the question. Was I speeding? Well, if my gears work and everything like that, then hopefully I wasn't. But let's try to figure this out. So this is a series of revolutions. This is actually really fun. So a series of revolutions. I start with what I'm given. Let's prove this police officer wrong. Maybe I was speeding. Okay? And this is RPMs. The RPMs was 2,100 revs per 1 minute. Okay? I'm going to use my railroad track conversions. I always need to make sure I multiply by 2 pi, somewhere in the problem, 2 pi radians per 1 rev. Because I need to know if I was speeding, so this is mph, right? That's really what I need. I need to know what my actual velocity was, what my speed was, my linear speed. So the revs go poofy. I then multiply by another conversion. Let's just say, oops. First, we need to know the diameter of my tires. This is unfortunate, because I totally forgot to click. Let's do it this way. I'm just going to recopy everything. Let's just say the diameter of my tires is 12 inches. Now, of course, that's ridiculous. No tire, unless you're like a clown car, has 12 inches and 12-inch diameter tires. Okay, so again, this was 2 pi radians, and this was 1 rev. And then I need to then multiply by basically this. This is my diameter. What's my radians? Then my radius is 6 inches. Why do I put it up here? I'll show you why. Because this is 6 inches per 1 radian. That means they go poofy. Okay, the revs go poofy. All right, so now what do I need to multiply by? Well, I need to start getting into distance, right? Miles. So how do I do that? Well, inches, I have inches. How can I convert inches to freaking miles? Okay, so it's 1 foot per 12 inches. So inches go poofy. Well, how do I get feet to miles? Well, it's 1 mile per 5,280 feet. Okay, and now last, I need the time. So we have 1 minute all the way over here, so 1 minute, because the feet go poofy. 1 minute, I need to look at that and say, well, 60 minutes is per 1 hour. So that way the minutes actually go poofy. So now what am I left with? I'm left with miles and hours. All the other conversions went poofy. How do I solve this? I literally multiplied 2100 times 2 pi times 6 times 60. And I get that and divide by 12 times 5,280. Technically what you should get, and I'll do it for you, is 74.97 mph. What does that mean? Was I speeding? Well, if you're a true Arizonian, you would know that the actual I-10 speed limit going up to the valley from CG is 75. So no, I was not speeding. Suck that, officer. All right. Here's what we learned. We learned the length of an arc, how to find it, the difference between linear and angular speed to describe motion on a circular path, especially with regards to revolutions. Okay? So here's everything. This is literally the last lesson before the quiz, the radians and arcs quiz. So remember, please do the homework quiz either today after you do the homework or before you take the quiz, the actual quiz, the radians and arcs quiz. Do this homework quiz, 5.1b, before. If you get 100% on your homework, of course, I will give 2 extra credit points on the homework quiz for you, especially if it's done on time and before you take the homework quiz. Make sure to use Google Classroom resources and Math Excel learning aids so that you can prepare adequately for this quiz. Remember, if it's a quiz, that means if you complete the quiz review before you take the quiz at 100%, then that gives you 5 extra credit points on that quiz. Okay? And if you're honors, the exact same thing. Now, you're maybe thinking, well, what if I do both? Do I get 10 extra credit points? No. Okay? You do not. You do not get 10 extra credit points. So just do one. If you're not in honors, you're just going to do this one. If you are in honors, you're just going to do this one. If you complete it before the quiz, boom, you get the extra credit. All right. Also, don't forget the Math Excel orientation. Remember, you need to also log in right here. Put your login information, put your username information. A lot of you still probably have yet to do that. That's an easy point. Do that. A lot of you probably have yet to even do the orientation at 100%. Do that. Make sure the pretest is done. Make sure all the other homework and homework quizzes are done. Okay? Yes. I think I'll probably take this arc length one off. I don't think I'm going to allow that one. So you don't need to do that one. So I'll probably take that one off. Isn't that great? That's great. Other than that, make sure the honors contract is due by tomorrow. If you're interested in honors, please have your parent or guardian email me to my email no later than Friday by 4 p.m. Okay? Until next time, I'll see you guys later. Bye, Phantoms.